In this segment, we're going to talk about how we determine the phase of a system. So, first thing we're going to do is talk about the state principle. It says for a simple compressible system, we need two intensive independent properties to fix the state of the system. That means to figure out all the other properties that we want to know about that system. Now, this is sort of a loaded statement, so let's take it one part at a time. Simple means that we don't have any electrical, magnetic, gravitational, motion, or surface tension effects. This means that we have no external force fields applied to the system. So if we did, we'd need another property to fix our system for each of those effects that are listed there. Now, fortunately for us in this class, we only work with simple systems, so we don't have to worry about this part of it too much. Compressible means that the specific volume can change. Intensive means that the property is independent of the size or the mass of the system. So temperature, pressure, and specific volume are the properties that we've talked about so far. And independent just means that they're independent of one another. And if one of those properties change, the other property doesn't necessarily have to change either. Now, temperature and specific volume and pressure and specific volume are always independent of one another, but temperature and pressure are not. They're only independent if you're in a single phase, so compressed or superheated. But if you're in the saturated region, if you're two-phase, then you have to be careful because those two properties are absolutely dependent on one another. At a given temperature, there's only one possible pressure that you could be at. So if you're at 4 degrees Celsius and you're saturated, the only pressure you could be at is 0.00813 bar. So if the only thing you know is temperature and pressure, you will know that you're saturated, or you can tell that you would be able to tell that you're saturated, but you wouldn't be able to tell whether you had a saturated liquid or a saturated vapor or something in between there. All right, so to use these tables, you need to know what phase you're in because you need to know which one of those tables that you're going to use, right? So the first thing you're going to do is you're going to look in your saturated tables, and that doesn't mean you're automatically just assuming that you've got a saturated substance. You're going there into your saturated tables and using the information there to figure out if you do have what phase you do have. Is it compressed? Is it saturated? Is it superheated? And once you determine that, then you go to the appropriate tables. All right, so we're going to develop some rules here to help us figure out what phase we're in going forward. And to do that, we're going to work through some problems. So here we've got water. It's at 10 degrees Celsius, 50 meters cubed per kilogram, and we want to know, is it compressed, saturated, or superheated, and we want to know the pressure. So the first thing I'm going to do is I'm going to put it in the right form. I'm going to list given, find, assumptions, solution. Assumptions, we don't really have any. These are simplifications that you make in order to make your analysis a little bit easier, okay? And we really don't need to simplify this any more than it is already. So the first thing we're going to do is we're going to look in our saturated tables. We've got ones that are organized by temperature and pressure. Temperature is probably more convenient because I am given a temperature here and it's at a nice neat interval. So I'm going to go the 10-degree line. And now I need to use the information that's in here in the saturated tables to figure out what phase I'm in. So I'm going to put everything on a TV diagram just to visualize it a little bit better. Here's my vapor dome. I'm going to draw a line corresponding to 10 degrees Celsius. And then I've got my pressure, that's my saturation pressure. So I'm going to draw a little line corresponding to a constant pressure of 0.01228 bar. Then I'm going to put my specific volume data on there. So V sub F, that would be 0.0010004 meters cubed per kilogram. And that would be at the location where the saturated liquid line and the 10-degree line overlap. Same thing with that V sub G, except it's on the saturated vapor line. And then I look over here at my specific volume, and I'm at 50 meters cubed per kilogram, so I'm sort of in the middle somewhere, which means that I am absolutely in the saturated region. So I'm already at my saturated tables, awesome. And the only pressure that I could be at 10 degrees Celsius and be saturated would be at my saturation pressure. And I'm going to box my answers so nobody's looking for my answer. And then I'm going to kind of make a note to myself that, well, if my specific volume, if it hadn't been at 50 meters cubed per kilogram, say it had been less than the V sub F value at 10 degrees Celsius, say it had been, I don't know, 0.0001, then that would put me in the compressed region. If my specific volume wasn't 50, it was, say, 115, so bigger than the V sub G value at 10 degrees Celsius, that would put me in the superheated region. So that brings me to my first set of rules. I have a two-phase substance or a saturated substance if my specific volume at a given temperature and pressure is in between the V sub F and the V sub G at a given temperature and pressure. So it works for pressure as well. The example problem dealt with the temperature, but it applies for pressure as well. I have a compressed liquid if I'm below the V sub F value, and I have a superheated value or superheated vapor if my specific volume is greater than the V sub G value at the temperature or pressure that I'm given. So I already have my first set of rules. Let's work another problem. We've got water at 100 degrees Celsius, 1 bar. We want to know if it's compressed, saturated, or superheated, and we want to know the specific volume. So I'm going to put it in the correct format, given, find, assumption, solution, and I need to figure out what phase I'm in. So I'm going to go to those saturated tables, and I can use the temperature tables or the pressure tables. I'm using the temperature tables, but I could just as well use the pressure tables. I just picked one. Right? So I'm going to go to the 100-degree line, and I'm going to use the information here. I'm going to put things on a TB diagram to help visualize and help determine whether I have a compressed liquid, a saturated substance, or a superheated vapor. So first thing I'm going to do, I'm going to put a little line corresponding to 100 degrees Celsius. Then I'm going to put my line of constant pressure corresponding to that saturation pressure at 100 degrees Celsius. Then I'm going to put my specific volume, so the V sub F and the V sub G values at 100 degrees Celsius. So those would be where the line for 100 degrees Celsius and the saturated liquid line meet, and the same thing with the saturated vapor line. And then because my pressure is not at 1.014 bar, it's at 1 bar. So I know I'm not two-phase. So which am I? Am I compressed? Am I superheated? Let's see. So what I'm going to do is I'm going to put another line of constant pressure here corresponding to 1 bar. So it would be right below that line for 1.014 bar. Obviously, this is not drawn to scale, but I just want to show that it is below that 1.014 bar. And then I just need to see where that green line, where the line for 1 bar crosses over the little dotted line for 100 degrees Celsius, and it looks like it's right out there in that superheated region. So that tells me I'm superheated. So I need to go to my superheated tables in order to get the specific volume. So that's what I'm going to do. My superheated water tables are organized in blocks of pressure. So I'm at the block for 1 bar, and all I need to do is read off the specific volume at 100 degrees Celsius in 1 bar. And it looks like it's 1.696 meters cubed per kilogram. And I'll box it, and now I'm done. So now I've got my set of rules. So I have a superheated vapor, like in this example, if my pressure is less than the saturation pressure at the given temperature. I have a compressed liquid if it's greater than the saturation pressure at a given temperature. And I have a saturated substance if it's equal to the saturation pressure at a given temperature. The way I remember that is, like, for a compressed liquid, your molecules are closer to one another than if it were in a gas form and as a superheated vapor. And so I just remember that, well, if my pressure is greater than Psat at T, I could just imagine that greater pressure pushing those molecules closer together into a liquid phase. So however you want to remember it works. Last problem, we've got water at 100 degrees Celsius and 50 bar. We want to know if it's compressed, saturated, or superheated, and we want to know the specific volume. There's my give and find assumptions and solution. Need to figure out my phase first. So I'm going to go to my superheated tables, not because I'm assuming it, or my saturated tables, not because I'm assuming it's saturated, but because I need to figure out what phase I'm at. So I've got temperature and pressure. This time I chose to look at my pressure tables just to kind of mix it up a little bit. So I'm going to go to the 50 bar line. And now I'm going to put things on a PV diagram. It just makes a little bit more sense. So I'm going to draw a little line corresponding to 50 bar. I'm going to draw a line of constant temperature. You'll notice the tails are flipped looks a little bit different from that TV diagram, the line of constant pressure. So my little purple dotted line, that's my saturation temperature at 50 bar, 264.0 degrees Celsius. And then I've got my specific volume, my V sub F, and my V sub G. So right where the 50 bar line crosses over the saturated liquid and the saturated vapor line. And let's see, I am at 100 degrees Celsius, so I'm not at 264 degrees Celsius, which means that I'm not two-phase, I'm something else. So I'm going to draw another line of constant temperature corresponding to 100 degrees Celsius, and it's going to go below that purple line. So there we go. And it looks like where that green line crosses over the 50 bar line is going to be in my compressed region. So that tells me I'm compressed, and it also tells me I need to go to my compressed tables. So my compressed tables were organized in blocks of pressure, and so I need to go to the block corresponding to 50 bar and just read off the corresponding specific volume. So I've got a specific volume of 0.001041 meters cubed per kilogram, and I'll box that so nobody has to look for my answer. So I've got my final set of rules. I've got a compressed liquid if the temperature is less than the saturation temperature at a given pressure. I've got a superheated vapor if my temperature is greater than the saturation temperature at a given pressure. And if it's equal to Tsat at a given pressure, then obviously I have a two-phase substance. Now, it would behoove you to memorize all these. You'll make your life a lot easier if you memorize this quickly. You don't have to go through that whole song and dance of drawing lines of constant temperature and pressure and all that stuff to figure out what substance you have. Going forward, if you just memorize this, that's enough to be able to fix your state. All right, well, I hope that was helpful. Thank you.